Hello everyone, I welcome back you all to my YouTube channel. If you are here for the very first time, I would like you guys to subscribe my channel for very quickly moment. Okay, on that note, let's move forward. The topic for today's is going to be the logistic regression model. And basically, I would be talking a hands-on model with all of you, and I'll be sharing the code of the PySpark as well. And the objective of the model is going to be to calculate the expected credit loss, which usually bank want to calculate. And it is one of the toughest part which many of the modeling teams are working on. And it's a credit risk model on the basis of the mortgage, like what is mortgage. So you guys will understand that how mortgage works, how basically bank give the loan to the mortgage backed securities. So that is going to be the agenda for today. On that note, without wasting your time, let's move forward and start discussing. And you can download the video also for your reference, and you can download the code also, which I will be sharing with you, and link will be there in the description box. So let's move forward. So guys, this is my Databricks free edition, which I have already explained in my previous video that how you need to install this. Okay, because Databricks gives you by default Spark is installed on your system. So you can see this is a community.clouddatabricks.com. So you can download it and you can just log in into it by using your password. So there are two ways. I explained it already in the previous video that how you need to download it. So we'll not go there. Now, the key thing is what is the objective of this model, because that is something we should understand. So let me just take you through this. So guys, you can see on your screen that we are going to create a logistic regression model in PySpark for mortgage portfolio and calculate the probability of default, loss given default, exposure at default, and expected credit loss. Now, what is logistic regression, which I have explained in the previous video? When there is a dependent variable and an independent variables. So basis on the independent variable, you are going to create a dependent variable which will give you some kind of prediction whether the person will default or not. So that is known as logistic regression. And the function which logistic regression uses sigmoid function usually. And logistic regression is moreover a probability model, because the probability is either 0 or 1. So similarly, the event will happen or not. The thing which we are calculating whether the default will happen or not, that is the end goal of this model. Now, what is mortgage? So mortgage means the loans, especially your home loans. So when we talk about homes which are backed by mortgage, that means that if bank is giving you a loan, bank can get the loan back if you're not paying the bank. How they can get it? By selling your property. They can sell your house without any hesitation, without any legal problem, and they will be able to get the money back directly. So that is known as mortgage. Okay, now probability of default. What is probability of default? What are the percentage a person will default? That is probability of default. What is LGD? That is loss given by the default. So LGD will change after every month because you pay EMI every month. So what is the loan bank will lose after a certain point of time if the person stop paying the loan? That is known as loss given by the default. Now, exposure at default. At a particular time, how much total exposure is there at the default, including principal, interest, all that value is known as EAD. Now, the fourth thing is ECL. So ECL is a product of three of them. When you multiply PD, LGD, and EAD, that is known as expected credit loss. Okay. Now, this is a model building video. So I'm going to build a model. Now, there are some steps which are involved in building a model. So create a data set for mortgage portfolio. Obviously in your company, you'll create a data set. It can be any data set. Like for you, it can be a credit card in your company. Here I'm using mortgage. Second is pre-processing the data. This is the most important step, because if the data is not processed correctly, then you will not be able to apply the right model in the right way. Pre-processing of the data is second step. Build the logistic regression using PySpark. Third step, calculate probability of default, because probability of default is a bit complex compared to the rest of the model. So that's why we do that. Now, the very important point to note here, guys, that probability of default we are calculating individually, because PD is the most important factor. Because see, the calculation of PD is not very simple. There are two type of PD. One is which is the third party gives to the bank. Let's say the data provider, the FICO, the Sibyl, all those company, they are the data company, they provide the credit rating. So they have the PD calculated for the customers on the basis of the history. Then there is a PD which bank calculates. So we are talking about that PD where the bank is calculating the probability of default of the customer. So here on the step 4 we calculated that, then we are calculating the LGD, EAD and ECL, and then I will run this code. So that is just a kind of algorithm I have given here. Now let's move on to the next step. Explanation of all the key concepts. Logistic regression model. So we build a logistic regression model using various features like credit score. These are the column names in the data. Okay, just make sure you know the column names like the credit score, loan amount, income, how much the person is earning, interest rate of the loan, then the LTV. LTV is a very important thing, like loan to value ratio. What is the LTV value of the loan? Loan to value ratio means like let's say you go to the bank, you ask for the loan of 1 crore. They are only approving like 80% of that. So rest of the 20% need to be paid by you. So LTV is 80%, that is 80 lakhs rupees. Okay. Similarly, for some people, it will be 90. The more, the higher the risk involved in the lending of the loan to the customer, the higher the interest rate will be there. So that is LTV. Then loan term, like what is the term of the loan? That is also very important. So these are the column we would be using in this particular example. Now, to predict the likelihood of a customer defaulting on their mortgage, so there will be a default flag which will talk about whether the customer will default or not. So 0 or 1. Now let's talk about the details of the model. Now probability of default. As I made you understand, the logistic regression model output a probability for each customer representing the likelihood of default. A customer with a higher probability is more likely to default. So that is known as probability of default. Now, so similarly, the definition for the LGD is there. The loss given default represents that the portion of the loan that would be lost if the borrower default. It is assumed to be the function of credit score. A low credit score leads to higher of the LGD, obviously. Now, what is exposure at default? So exposure at default represents the amount of loan at the end of the default. Like when the default happened, what is the EAD? In this simplified model, it is just the loan amount. Simple way. Okay. Now what is ECL? ECL is calculated as PD multiplied by LGD EAD. It is the total expected loss based on the probability of default and LGD and EAD. So that is being calculated. Now in the data which I will be using, these are the column names. So I already told you customer ID, credit score, loan amount, income of the customer, like how much that customer is earning, then the default flag, whether the customer has defaulted or not in the past, then interest rate, then LTV, loan to value ratio, or sometimes we call it CLTV also. Okay, so that is the same thing. Now loan term. So the first step is you need to import the packages of PySpark. What are the packages you are importing? SQL for Spark session, then machine learning package, classification, features, and normal ML for the pipeline. So you are building a logistic regression, you call that, then a vector assembler, where the use of vector assembler is to put all the variables in a single vector that will be used for the further calculation. Okay. Similarly, in this PySpark ML with pipeline, because you are going to build a pipeline, you will understand all of this going forward. But just make sure you have to like memorize this. Just memorize this simply when you are building a logistic regression model. You need to use this because you will be using all these functions going forward, and the use of each this function will come in a while. Let me go forward. So the first step is, okay, initialize the Spark session. So in this line, you are building a Spark session, and the command is spark session dot builder dot app name, and then the mortgage default prediction. You can do any name for your convenience. If you are building for credit card, then credit card default prediction, whatever is your choice, you can do that, and then get or create the method. So this is the line number 1 in your code, which you should mention as a step. So now you have created a Spark session. So second step is reading the data. Why I'm taking a small data? So that I can make you guys understand, because if I take a large data, which is a real time data like 1 million observation, that is going to be really confusing for you. I don't want to confuse you. Now here, if you see, so these are the columns. Okay, I already told you about the column name, but you see this is customer ID, then this is your credit score, this is your loan amount, similarly this is your income, This is your default flag. It's either 0 or 1, you can see. So these are the column I'm highlighting, guys. Then you have the interest rate, then you have the, this is your interest rate, then you have the LTV value, and then you have what? Loan term. So all these data is there. So this is your step 2. Still we would be continuing with step 2. In the step 2, what you are doing, you are preparing a column. You are basically preparing a single kind of, I would say, a container where you are keeping all these variable, and then you are creating the data frame. Now how will data frame will work? Df equal to spark create data frame, then data you will pass this whole data, and then you will pass the column name. So it will give the name in the sequence. Then this particular part, line number 70, is to see the data whether you have got the data correctly or not. That's why I'm doing df.show, because this will show the data. Now the next step will be data pre-processing. That is very important. We have done the variable selection, that is feature selection is already done. Now feature engineering, we will create a feature using this particular vector assembler for all these columns which we want. Now assembler, where is assembler? If you see on the top, we are using this because we have the vector assembler. That's why we are able to use this assembler here. So what the assembler says, vector assembler, this is creating a vector. Vector is what? Like a single column from multiple column. That's what we are doing here. So input columns is this. All these input column will go in a single column called feature. So this is your step 3, which is your data pre-processing, where you are creating the vector or a single column which will contain the value of rest of the column. Next step is splitting the data into training and test data. So usually 80% is your training data, 20% is your test data, and seed is anything you can give as a seed. Here if you see train data set, then test data set. So this is the syntax. 80% of data will come here, 20% of data will go there. Now df dot random split, that is a function we are using, 80-20, and seed is 40. So that if you have millions of observation, every 42 observation will be divided into 2 parts, 80 and 20 level, and it will be unbiased. So you will get the data in your 4th step. Data is ready. Now 5th step, to create the logistic regression model. So LR equal to logistic regression, then label column default flag, that will show you whether the person is defaulted or not, and then you are keeping all the independent variables. So these are the features, which is the vector, and these are the independent columns, and this is the dependent column because this is dependent on this. Now create a pipeline using pipeline equal to pipeline stages assembler and the logistic regression model. That's why it's important. So basically you are trying to create a pipeline here, and then you are building a model on the which data? First the training data, which is your 80%. So training data will come here, model pipeline dot fit. It will check the fitness of the data, whether it is fitting in the pipeline or not for the training data. In step number 5 we do that. Then what you will do, you will do the testing of the data. In step number 6, prediction equal to model dot transformation. You are able to use this model because you called it in the initial libraries, right? So just remember that. Then show the predictions. In prediction, what are the things you want to show? Like predictions dot select customer ID, prediction, probability, and dot show. Now calculate PD, probability of default from logistic regression. Prediction contains the default probability, 0 for non-default, 1 for default. If 1 will come, the person has defaulted, 0 non-defaulted. Probability column contains the probability score. That's very clear, right? Extract PD from the probability, and then you just print it here. So prediction equal to prediction dot with column, then PD call, we are pulling it again the function from the library up there, and then get item 1. Show PD for each customer. So in this step we have calculated the PD. Now we'll move on to the LGD EAD stuff. So that is very easy. We are creating a user defined function, calculate LGD, then credit score taking in the consideration. If credit score is less than this, then it will return this much. If credit score is less than this value, then this will give you the value of this. This is the moderate loss for average credit score. So based on the credit score, you are defining the LGD. Then register UDF to calculate LGD. Basically you are registering the LGD, so that's okay. Then in this line, prediction of LGD on the basis of the credit score. That's what we are doing. Predictions dot with column LGD, and on the basis of the credit score. So that's how this code is flowing. Now let's go forward. Predictions equal to prediction dot with column EAD, similarly like we did for LGD, and then we are doing for EAD. and calculate the ECL on the basis of what? So see, EAD we calculated on the basis of loan amount. Similarly, ECL we will calculate on the basis of, if you see the common thing, with column is the common one, and prediction dot with column is the common function which you are going to use. The only thing is like the inside columns are changing. So for the ECL, what you will use? ECL you will be using PD, LGD and EAD also, which you cannot see at the moment. Let me show it to you. I think, let me zoom it out. Okay. So basically ECL is a product of three of them, and then you are just representing that in the last and you are showing the data. Now what I can do, I can run this code simply. This is going to be pretty simple. Let me go to the top. So you will be able to download this piece of code and you will be able to run this. Just click on this, select resource. So there is no cluster at the moment. Let me quickly create a cluster. Click on new, then cluster, and the name of the cluster be let Rajat, and create compute. So it will be creating cluster for me where I will have the PySpark installed, everything will be there. So I just need to run the code. Let me quickly do that. So guys, it hardly took couple of minutes for me to create this cluster. Okay, I'll go back to my recent page again. I'll remove this. So logistic regression for PD, LGD, EAD is the name of my file. You will be able to download it from the description box. I will put it in my GitHub. Let me run the code, select resource. It will ask for the resource. I'll click yes. So it's running. You will be able to see the output after this. So currently it's running. It takes couple of seconds sometime. So Spark job has popped up and your output will be shown here in this particular value. So you can see the data is prepared, right? Customer ID, credit score, loan amount, income, default flag, interest rate, LTV and long term. So all of the value you have. Now let's do the pre-processing thing. You will not be able to see the output here, guys, okay? Because I'm not printing the output. But now you will be able to see the split of the data. Let me run this. You can see that the data has been splitted in two sections. So one is your test data, then you have the train data. Let's run the regression on the model data. This is the point where I'm running the regression. So you will have the data ready. The most important step. That's why we are building this model, so that we can understand all these things. Spark job is completed. Yeah. So this is completed. Now let me run the prediction part, because here you will be able to see it. So you can see that customer ID 1, which is the predicted value 1. So the customer ID 1, where we have the customer ID 1, that person will be able to default. That's where the probability of default is coming for this customer. Now let's calculate LGD, EAD and ECL. Let's run this part. So you will be able to see LGD, EAD, everything. Okay, I think this could not. What is the error it's showing? Let's check the error also, guys. A column or function with PD cannot be resolved. Okay, that means that there is something wrong with the PD part. Let me quickly check on this. So guys, basically what I have done, I have pasted the whole code in a single cell, because this session on Databricks was giving me an issue. So now this whole code I have pasted in a single cell, and I will be running this whole code, and you will be obviously able to download it from the description box. Let me run this code. So in the output, it's saying there is this invalid syntax. This session is actually corrupted, but let me quickly check this on the line number 1. So this is something which is left uncommented. Let me do it. And okay, we have commented this line number 1. Now only the code will execute. Let me run this piece of code. The whole logistic regression is running now. So guys, let's see the output. Okay, so guys, you can see that this is the output basically, okay, and this is the data, and this customer number one will default only. That's how it is showing it currently, and in the output it is showing you the whole data, and then this is the flag, this is the prediction. That prediction one means what? I just explained it to you when we were starting, that prediction number one will be equal to that person will default. So that's what we are doing at the moment. Now this code I would encourage all of you to download, okay, and you can download it from the description box and you will get this code. So now download this piece of code and try to learn by your own self, and if you have any question you can please comment and I will help you out. So on that note, I hope you find this video helpful. So please subscribe to my channel if you're for the very first time on my channel, and please like and please share this video with your friends and family. Thank you so much guys. I'll see you in the next video.